Good day, everyone. It is my privilege and honor to present our PCIEERD funded project entitled as 3R Approach to Sustainable Management of Nickel Laterite or Mining Waste, Reuse, Recycle, and Reprocessing for Environmental Remediation and Material Valorization. I would like to take this opportunity as well to thank and acknowledge our industry partner, AMV, Agata Mining Venture Incorporated, for being our collaborator for this project. I also would like to acknowledge Steyan, where we obtained our coal fly ash in order for us to proceed with our development of geopolymer materials using this waste or industrial byproduct. The 3R program actually is an 18 million DOST funded research program wherein it involves 4 component projects and 3 research-oriented universities. These are the LSU or the Lasal University, Central Mindanao University or CMU, and MSU IIT. And of course, this involved more than 20 researchers. The project that I am leading is actually on the application of geopolymer to recycle the mine tailing, the mine silt or waste rock as a potential cementitious end product. And in this case, our project uses both coal fly ash and mine waste from the nickel laterite mining area in order to produce this eco-friendly material through the geopolymer technology. Please allow me to share my video on how we envision this geopolymer technology, this research that could have an impact to the society.
If there is someone who could imagine the potential of industrial waste from thermal power plants or rice hull ashes from farms across the country, it would be De La Salle University Chemical Engineering Professor Dr. Michael Angelo Promentilla. Promentilla and his research team named GAMERS, or Geopolymers and Advanced Materials Engineering Research for Sustainability, are responding to the global call for a low-carbon circular economy and sustainability by developing a construction material that can be an alternative to conventional cement, the geopolymer. Promentilla's research on coal ash utilization and geopolymer technology started in 2013 when he received a seed grant from the National Academy for Science and Technology. The project is a response to environmental threats that come from the rapid growth of urban and industrial areas in the country.
If I'm not mistaken, there's about 300 million tons of this coal ash here in the Philippines. It's one of the byproduct of coal-fired power plant. So makita ninyo yung kuryenteng ginagamit natin ngayon is in fact mainly 40% of that came from burning coal. And one of the byproduct of this coal-fired power plant is coal ash. So we're trying to find out whether this coal ash, which is actually an industrial byproduct, or you may call it a waste, can be used to produce a geopolymer-based material that can be used for building, for road pavement, and so on.
Promentilla's research also led him to look into the agricultural sector, which produces a large amount of rice hull and waste abaca fibers, which are abundant natural and raw materials. He found a use for these in reinforcing the geopolymer matrix. 3 applications of geopolymer are being explored: a fire-resistant building material, an acid-resistant material, and a geopolymer reinforced by chemically treated waste abaca fiber. Promentilla's team is collaborating with researchers from Mindanao State University, Iligan Institute of Technology, and Central Mindanao University to study the possibility of using mining waste in manufacturing building materials.
That's what I dream about with this technology here in the Philippines. We started 5 years ago, and hopefully after a decade, it will be more accepted. There will be regulations that would enable the use of this kind of material.
Thank you very much for your time. And of course, right now, we are on the path of commercialization under the funding of a fast track program. Hopefully, I can give you update in the next progress of our research. Thanks again.